Hey everybody, in this recording I am going to go over how we would solve this particular equation. This equation right here is a polynomial. We like that this equation is already set equal to 0. Anytime you have an equation that is bigger than linear, quadratic, cubic, quartic, quintic, and so on, you want to make sure you get it equal to 0 because the way we solve is by using linear factors whenever possible. Now, normally what you would try to do to solve, since the directions say solve, that means solve for the variable, in this case x, is you would try to factor the problem. Now, this is a quadratic equation, which would be in the form 𝑎𝑥² plus 𝑏𝑥 plus c equals 0. This is a quadratic equation, and when we want to factor something like this, we'll probably start with trying the AC method and grouping. So you would do A times C, which was 9 times 4, 36. Then you would make a list of all of the factor pairs that multiply to give you 36. And from there, you would try to find a pair that multiplies to give you 36, but, B for but, when you get to the bottom of the list, but adds to give you -6. But again, if we try to do that for this particular example, we will not find any numbers that make that true. So I'm just doing this on a little scrap piece of paper. I'm gonna take this away in a minute. So I'm not keeping it on the screen here. So again, if we tried A times C, which was 9 times 4, we would get 36. I would find all the pairs of factors, 1 and 36, 2 and 18, 3 and 12, 4 times 9, which is what we just did. 5 does not work, and then 6 times 6. That's the bottom of the list. When you get to the square root, you're usually at the bottom of the list. Well, you're always at the bottom of the list. From that, bottom of the list, B for bottom, but B is -6. So we find, but what pair adds to give me -6? Nobody. Okay? When that happens, it means it's not factorable. Okay? Not factorable, and maybe you feel sad, but no need to be sad. It's okay. We have the quadratic formula. We want to memorize the quadratic formula. So again, these both start with the word quadratic. Now, alphabetically, equation and then formula, E-F, right? We've got A, B, C, no D, E-F. Equation, first you have an equation, then you could try to solve the equation and you use the formula. So use the right words. Equation is this. Quadratic formula is the special formula that we use to fix this problem that we have where we can't factor it. Okay, so we use a formula. We fix the problem, another F word, that we can't factor, F word. So we're going to use a formula. That formula is x equals -b plus and minus the square root. You need to show, if you look, my square root goes and I put a little tail at the end. Maybe you don't draw your tail yet. The tail has to close, that I just like to make sure I close it at the end of the special expression underneath the radical. X equals -b plus and minus the square root. What's the square root of? B squared minus 4ac. All of that has to be under the roof of the square root. So make sure when you write this in your notebook that you have your roof of your radical, of your square root symbol, going all the way over the b squared minus 4ac if you want full credit, okay? And then all over, that's another thing. Make sure from negative all the way to the C is all a fraction bar. So it's all over 2a. So again, if you don't have your square root roof going all the way there, you don't get full credit, guys. And if your your division fraction bar isn't going from the negative and the negative b all the way to the end of your root, not full credit. Do not put the fraction bar to the other side of the equal sign. That's silly, okay? So that right there is your quadratic formula. Couple things. I'm going to throw a little vocab at you. So this piece underneath, b squared minus 4ac, it has a special name. b squared minus 4ac. The first name that I'm going to give you is the name of anything under a radical. Anything. Okay? So anything, this is like the big umbrella name. Anything under a radical symbol is called a radicand. However, this one, so this is what we call like, think of it like a subset, right? So like everybody is a student at this high school, you know, from here to here, you know, this person to this person is a student at this particular high school. However, only, you know, these 17 people, 18 people, whatever, are students in this class. So the students in this class is what we would call a subset of the larger set. So the subset is a more specific group. So the subset, or the more specific name for this one, this radicand is called the discriminant. Okay, watch your spelling. But this radicand, is called the discriminant. And it does sound like the word discriminate. And it does sort of do that. And we're going to talk about that later. But whether the radicand or the discriminant is positive, negative, or zero will tell you something about your answers. So it's kind of like discriminating against certain answers. So it's like, oh, if it's positive, it's this. And if it's negative, it's that. And if it's zero, this happens. So like different things happen. So, you know, there is that relationship there. Next. So hopefully we all jotted that down. Next thing we're going to do is I'm just going to go and I'm going to label, I'm going to write myself a note. A equals 9. B equals negative 6. C equals 4. And I'm going to start filling in to this quadratic formula right over there. Okay? So that would be x equals, nice and neat, best as we can do. Now it says negative b. Remember that the word negative means opposite. Okay? So I'm going to put a little arrow and a star, and I'm going to write negative really means, so negative means opposite. It doesn't mean just always negative. If it is negative, you make it the negative of negative, which we sound like crazy people, but you make it positive, okay? So negative b means opposite of b. If b is negative 6, I put positive 6. Next, plus minus the square root. B squared. Whenever the b is negative, I advise you use parentheses. I've warned you guys that if you don't use parentheses and you try to use your calculator to help you, that it is going to give you the wrong answer. And I know, I think it might have been Paige asked a good question. It was like, well, I typed this in my calculator and I didn't get, you know, that thing. Why is my calculator lying to me? And I think it was was it page? Maybe, I'm not sure. And it ended up being,
Yeah, I think it was when,
it was like a similar situation to this one.
yeah.
Yes. So we always want to watch out for that. And the square goes on the outside of the parentheses. It does matter. Okay. If any of you end up, doing anything with computer programming in college one day, which probably a lot of you will, or if you end up using spreadsheets in your job to organize data, and you will type formulas probably into those spreadsheets. And I'd love to show you guys one day, a couple simple formulas to really make your lives easier. If you don't put parentheses in the right place, well, it's going to mess everything up. So you want to watch out for that. B squared minus 4ac. A was 9 and C is 4. So now I'm closing that radical right there. All over 2a. And remember, parentheses like this, that it means multiplication. So I'm even going to go a little extra. Let's even put some dots to really reinforce that we are multiplying. So it's 2 times 9. All right. Now, I even gave you guys a whole breakdown and setup of, if this is minus 4 positive positive, minus 4 positive negative, negative positive, negative negative, what happens, right? Should that be a plus sign or a minus sign? Because I know some of us ride the struggle bus with positives and negatives, and I'm trying to help you out. So let's move on. 6 plus minus the square root. Negative 6 squared is negative 6 by negative 6. You make a square. So it's a negative 6 by negative 6. Think of like Lowe's. You get a piece of lumber and it says 2 by 4. Blank by blank. What is that showing you? Dimensions. Cross section. If you cut it across section, what do you see? So a negative 6 by negative 6, what does that make? It makes, well, negative numbers, it's a little weird, but it makes a square. That's why we say squared. That becomes positive 36. I literally bought these pens yesterday and I just opened the package. This cannot be happening. Come on, you can do it. I'm gonna have to switch colors. So it becomes positive 36 minus 4 times 9 times 4. 4 times 9 is 36. We already did that a few minutes ago. Whenever you do times 4, though, remember you could do times 2 and then times 2 again. So like 9 times 2, 18. 18 times 2, 36. 36 times 2, 72. 72 times 2, 144. So, you could do things like that. It's up to you. So there's 36. Try not to touch your calculator. Minus 144. Another way I would do 4 times 9 times 4, what I find myself doing, I'm just going to grab a little scrap paper there. But say you did 4 times 9 times 4 and you did 36 times 4. I might think, well, wait a minute. 36 is 6 times 6 and 4 is 2 times 2. What's 12 times 12? Well, 144. Or maybe you did 4 times 9 times 4. Maybe you did 4 times 4 first and you have 16 times 9, right? And you're like, 16 is 4 times 4. 9 is 3 times 3. What's 12 times 12 again? 144. So, always look for good methods. Okay, so minus 144. So this radical is a little long. All over 2a. So 2 times 9 is 18. I think most of you should have been able to get kind of up to here on your own pretty decent, right? Like without too many mistakes. Now, we have a small number, 36, minus a much bigger number. What's going to happen to our answer if we have a number and we're taking away more than what we have? You could just shout out if you know what's going to happen to our solution for inside the radical.
It's going to be a negative number.
Good, it's going to be a negative number. So we have 6 plus minus the square root of. So whenever we do something like this, different signs, we have a positive 36 and a negative 144, we subtract. So I'm going to do 144 minus 36 in my head. 36, 4 more gets me to 40. 4 more after that gets me to 44. So that's 8. And then 100 to 144, right? So what's the difference? 108. We subtracted, but we take the sign of the bigger of the two numbers. So 144 is bigger. It's negative. So this should be negative 108. Okay? So if you got that, give yourself 2 thumbs up. All over 18. Don't try to reduce anything yet. You cannot reduce until you kind of pretzel it up where the 6 and 18 will reduce, and not 18 and 108, but the number that ends up coming out in front. Okay? So this might be where we start losing some people. What happens to this little negative? We have a negative in a radical, and we're taking the square root. And a square root is like, what number times itself equals this? But what number times itself is a negative? What number times itself makes negative? What number times itself is negative? Does anybody know what we do in this situation? Look at your notes from our last class.
Imaginary numbers.
Yes, we have an imaginary number because there's no real solution. There's no real answer to that. When you square something, you multiply it by itself. You will always get a positive answer. So when someone says, what's the square root? The roots are where we come from, right? Of a negative, no real answer. Well, if it's not real, you don't got real friends, maybe you got imaginary friends. All right, do you, boo? So 6 plus minus. All right, I'm gonna leave a little room. That negative, that's Simone Biles. Flip, 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 boom. She lands, throws her hands in the air, flawless. She's the imaginary number I on the outside, okay? Lands on her feet. So flips, lands on the outside of that radical. No more negative inside. But the 108, I still need to work with the 108. I need to simplify the 108 and take out any perfect squares, any pairs of numbers. So in order to do that, I'm going to take 108 and I'm going to make a little factor tree with it on the side. So here's 108, and I'm going to break this number down. 108, I like to start with 2 whenever possible. 2 times, well, half of 100 is 50, and then half of 8 is 4. So 2 times 54. Let's go and cut it in 2 is the bottom. We can't go more than that. 54, let's do that. 2 again times what? What's half of 54? Well, what's half of 50? 25. Half of 4 is 2. 25 and 2 makes 27. I should not have circled that one, so we'll double circle it when they're done. So that's circled twice. I guess we'll circle that once because I'm a dummy. Next, 27. I'm going to be a little cheaty because I can go a little quicker. I know what is the full breakdown of 27. So I'm going to have 1, 2, 3 numbers over here. Blank times blank times blank. If you know it, you could shout it out. What times what times what is 27? Since Jabari and Sol left their hands up, maybe they wanted to answer? No? 3 times 3 times 3. So my prime factorization, okay? A prime factorization means numbers that cannot be broken down any further. Go ahead, what's your question, Paige?
So what I did, for 108, I did 9 times 12, and then I did...
Okay,
like,
wait, pause right there. 9, here's 9.
Uh-huh.
I'm going to put dots under them. 9 times 12, right? 3 times 2 is 6, times another 2 is 12. That's fine. It makes the same numbers at the end of the day.
Yeah, because that's what I did, and then for 9, I got 3 times 3, and then for 12, I got 4 times 3, and then I broke down the 4 to 2 times 2.
Exactly. You'll always have the same answer for a prime factorization no matter what. So that was perfectly fine. You could do it that way. So that means instead of having a 108 inside, so the I already came out. We have 2, 2, 3, 3, 3. 2 times 2 times 3 times 3 times 3. And how do we get out of a radical? If you remember, we did the troll, and he was only letting the little billy goats cross if they went in pairs. So 2 times 2 and 3 times 3, those are pairs. They're perfect squares. If that comes out, we just bring it as a 2. If that comes out, we bring it as a 3. Do you see this? I literally just opened this package of pens and it's drying out. Hello, paper mate. I'm going to complain. These are brand spanking new. So 2 came out, 3 came out, and a 3 is left inside. 2 times 3 on the outside, though. What's 2 times 3 on the outside? I'm literally taking the little rubber piece off the tip and everything. Sillies. 2 times 3 is... Thank you, 6. So that 6 root 3 is how we simplified radical 108. So 6 comes out, 3 stays in. 6 comes out with the I, 3 stays in, all over 18. Now, if you made it this far, whew, you get a sticker. Like, this is nice. We can do one more step, though. We can do a little pretzel action. I'm going to make a little lumpy pretzel. Okay, there's the one loop of my pretzel. Here, I guess I could make this whole thing a loop. What an ugly pretzel, but, you know, it still tastes good. This oval we reduce and that oval we reduce. What number can we reduce from each of the 2 parts of the pretzel? They actually both reduce by the same number. Coincidentally, that won't always happen.
6.
Yes. When you reduce 6, reduce, remember, you're not canceling. Cancel means 0. 0, 0. When you reduce or simplify, 1. Think you draw a line through it like that to cross it out. And it becomes a 1. So when we reduce 6 and 18, that's a 1 and a 3. And then this 6 and 18, still 1 and 3. So 6 reduces from everyone. That leaves us with 1 plus minus. Now, I'm going to write it 2 ways. You could write 1i root 3 all over 3. Or perhaps, and remember when we did I told you guys make sure that you are really specific that this is a 1 and this is an I. So do you see I'm making the dots on my I heavy and dark, okay? My 1s, I'm putting the little hat on it. If you want to put the hat and shoes, maybe like this, give them a full outfit, you could do that. But that 1 in front of the I you don't really need, so I could also have just written 1 plus or minus, plus and minus, I square root 3 all over 3. And there you go. Beautiful. So that is the real final answer. So I'm going to circle this whole line down here because they're both acceptable. There are 2 answers here. Okay. Now, Liana, you asked a question about the decimal. When we have imaginary numbers, we do not at all touch the calculator because you can't like get a decimal when I is involved. Okay, so don't even touch it. I don't know, did you accidentally, maybe you got a positive under your radical? And
No, so what I had did was after we got to the point with the 6 plus or minus the square root of negative 108, I had used my calculator before you said not to, because that's when I asked.
Gotcha.
To like simplify 108. So, and then that's where, because you did the imaginary thing, but I wasn't even thinking of that. So I was trying to do it the way we were doing before you.
Gotcha. Right. So before we had quadratic formula, if it were a positive 108 and I asked you for the decimal, absolutely you can do the decimal for the square root of 108 and then 6 plus that, 6 minus that, both divide by 18, you would be perfectly correct. But as soon as you guys have a negative in that radical, don't touch the calculator because you can't like have imaginary with decimals over here. We leave it with the radicals. The radical 3 is also called an irrational number, and that also starts with an I, imaginary and irrational. So they're buddies. You have two I's, they go together, okay? They come in pairs, plus and minus. Your I's, imaginary and irrational, come in pairs, okay? And we all have one good eye and one bad eye. One of your eyes is better than the other. Pay attention when you wake up in the morning and the light, first hits your face. We all kind of close one eye. So you close your weaker one and you keep your stronger one open. So pay attention to which one you do. And we'll take a poll next time and see what our strong eye is. So that is what you should have copied down in your notes. And if you had a mistake, then, you're just going to either correct your mistake if it was something little. If you straight up scribbled a lot, that's okay. No big deal. But if you understand what to do, give yourself a high five and a thumbs up. I'm going to give you a homework problem now. So not only are you going to submit this for part of the classwork, but I'm going to give you a homework, and we're going to really do the same thing. You're going to use quadratic formula to solve again. You should get a negative number under your radical if you're doing it correctly. And then you should be able to kind of go and simplify with I. Take your time. It's just going to be one example. So you're going to copy that homework problem down now. This is being recorded, so this will be on YouTube for you guys. So if you needed to rewatch it or something, you could do that. So I'm going to call this OYO. This stands for on your own, okay? So for your assignment, you're going to, on your own, solve. Let's do 16x squared plus 20x plus 25. Don't be afraid of the big numbers. Just go nice and slow. They work out pretty nicely. Equals 0. So again, I'm giving you the happy 0. It's already happy and set equal to 0. The 0 with the big round Elmo nose. All right. And you're going to solve this the exact same way. You're going to show all of your work and circle your final answer. You're going to simplify all the way. There's our little Elmo face. Something like this. I don't know. There we go. He looks small. Cookie Monster has no nose, right? And he's cross-eyed. Do any of the other guys look like this? I don't know. But it's like a, one of these happy Sesame Street characters. So you're going to solve that. You're going to use quadratic formula. You're going to show all work. And then next class, your warm-up, I'm going to give you the answer video. I'm going to pre-record it. You're going to do exactly what we just did. So half your grade is how you do on your own solving this. Submit it on Classroom. And then the other half of your grade will be, after you watch the answer video, did you correct your work and resubmit a new picture with corrections or just totally recopied? All right. So if you understand what you're supposed to do and copy down this example and you watching this video, give it a thumbs up for yourself. If you are very, very confused on this and you want more practice, but you're too shy to ask, then put a thumbs down on the video on YouTube and I'll know that we need more practice and we shouldn't move on to the next topic. Okay. And that is it for this recording.